In this video, I'll show you the key steps in organizing your project well. So first of all, create a dedicated project folder. Don't just put it in a subfolder of a subfolder of a subfolder, but put it somewhere where it makes sense on your system. And then in that project folder, create this specific folder structure. First of all, a folder for your raw data. Second, a folder for your source code. Third, a generated folder which holds all the generated files. This is actually a folder that you can completely wipe later because your source code and your raw data, the combination of both, actually will reproduce any generated file in this project. But then you still have to make a difference between different components of your project, namely temporary files that are not at all important, output files which are the final product of a particular stage in your pipeline of your project. And it's also good practice to have an audit folder in which you kind of separate out files that tell you about the health of your data collection or any particular problems with missing variables when preparing data or any problems in model estimation such as non-convergence issues that you may want to take a look at. Number 2, define and create pipeline stages. Well, you've heard me talking about pipeline stages, but what is it really that I mean? Well, I urge you to think of your project in particular stages, maybe along the research process, right? So first, you obtain raw data, then you prepare those data sets for analysis, you analyze them using a statistical model, and then finally you produce a paper. These pipeline stages can be separated out because maybe eventually during the course of the project, other people will, work in different pipeline stages. And that way you can keep things very tidy. At the same time, if it's well organized and later on automized, you can very, very easily run the entire project from preparing the data up to that final table without much hassle. How do you create such directories? Well, I suggest you to create subdirectories in each of your target main directories. So, for example, the source code directory will have 3 subfolders: data prep, analysis, paper. In the generated folder, you'll have different subdirectory names for each of your pipeline stages. Then it's time, number 3, to plan each pipeline stage very well. So typically when you start out writing code, you'll write like there's one huge file that does everything, right? But this is not the way to go forward. Actually, you need to separate out that, huge code file into like small and manageable chunks that do like one little thing, such as like unzipping the data, such as loading the data sets again and merging them and writing an output file to your temp file. You see that this way your project becomes very modular, and the good thing really is that thereby you can very easily know to find where you've written code, but at the same time you can also very, very easily swap different parts of your projects and rerun the entire pipeline. The output that you generate in each pipeline stage varies per pipeline stage. When you prepare data, a logical final output is a data set of that pipeline stage. If you're working in the paper stage, probably it's a PDF report of your paper or PNGs, like images generated that you can put in your paper. Think of other pipeline stages too, such as launching an app to explore your results. There are tons of ways in which you can think about what an output is of a pipeline stage. So here are a couple of examples of pipeline stages I've worked on, such as a data prep pipeline. So first of all, I would download data sets, for example, public data sets from the web. Then I would load other data sets from other sources, such as from Excel. Then I'll have a little script that merges these data sets. I have another code file that generates some derivative data sets, like aggregating them from the daily level to the weekly or monthly level. I got a script that saves these final data sets so I can use them in later pipeline stages. And I'll have an audit markdown document in R that helps me auditing these files, such as generating basic descriptive statistics or some plots that allow me to judge data quality here. The example in the analysis, you may want to load the final data sets from the previous pipeline stage and then estimate maybe models on both the weekly and the monthly data set and systematically compare those models, and then finally have an algorithm choose the best model and save that. And you're going to pass on those results to the next pipeline stage, your paper pipeline stage, such as produce tables and figures for your paper and then produce a slide deck. Such dependencies can also be visualized in a chart. Here's an example of a different pipeline stage. How to read this? Well, the 00 download data are prepares some data and saves this into a tab separated file, which is passed on to the next pipeline stage to filter and reorder the data set, and then that produces some final plots. How do you start building your pipeline? Well, chances you already have some code written up. So the first thing is that you need to, separate that out into these particular pipeline stages, such as maybe data prep, analysis, paper. But, depending on what project you're working on, your pipeline stages may be entirely different to the ones that I'm talking about. It's a very general concept. And then the second thing that you do is you break up those long, make all the things scripts into discrete manageable chunks, different little components. And each one of those files reads in some data, that's the input stage, does some transformations and outputs some data or some object, which is then passed on to the next part of your particular pipeline. What's the advantages of perceiving your project as a pipeline? Well, number one, you actually document your workflow just by adhering to that pipeline structure, which makes it very, very easy to communicate with colleagues about your project and your future self, such as me looking at either my past work or my current work that I haven't really taken a look at for a couple of weeks. And then number two, when you do modify a stage of the pipeline, you don't have to rerun the entire pipeline, and that saves you tremendous processing resources. And then finally, you want to reproduce your entire workflow with automation tools. And I'll show you how that works in the next step, which is step number 4, automate your pipeline. What's automation? Well, it boils down to a set of rules, like instructions for a computer on how to do things and in what order. And we write them in so-called make files. Each make file has rules in it, and each rule essentially consists of 3 components. Number 1, what to build. We call this the target. What does it need to build those targets? We call those the prerequisites. And finally, how to build it. What commands actually to issue to build the target given the prerequisites. And then this tool make just builds the project knowing these rules. And rules also depend on each other. So it's just not one rule that you put in there, but a rule which again depends on the rule, and you kind of probably see where this is going. So how does a rule in make look like? Actually, it's quite simple. So you will first start with your targets, then you have a colon, and then you list all those prerequisites with spaces as a separation character for the target to be built. And then finally, you get a list of commands that is actually instructions to a computer on how to run it. Let me give you an example. That makes it a little more clear. So it looks a little complicated because I'm using already directory names here, but actually it's quite simple. So let's focus on the file names. I want to build an aggregated data frame. By the way, the choice of name is really arbitrary here. How do I build this? What are the prerequisites? I need the input data, listings.csv and reviews.csv, and a little code called clean.r. How to build that target? I call rscript, which is a little tool within R, so that you can run R scripts from the command line. So without opening RStudio or the traditional R graphical user interface, you could just issue a command on your command line. And here, this is done by calling the R script program and telling this R script program to run the script clean R. Well, you may wonder, why is clean R part of this command and also part of the prerequisites? Well, make checks changes to any of those input files because it wants to rerun this rule as soon as one of your input parameters, like your prerequisites, changes. And probably one of the most important inputs to building a target is the source code that you're writing. When you make changes to the source code, you want make to realize that the target needs to be rebuilt. And that's just what's done by putting your code you use to run this whole stuff also as a prerequisite. Right now, I'm showing to you one of my projects, and I'll open up the terminal. Observe it's in data preparation. I could also write present working directory. I get the folder where I'm at, and by writing make with a flag -n, actually I get a preview for what would be run if I was gonna run make. So already here I see that all my project has been built. And as soon as I start changing one of those input files, so I just suppose I've changed my source code and I reissue make -n, then actually I get a set of rules that make would run now to build my entire project again. And by typing make now, I actually make my program run these things. I sometimes have very, very complex pipelines, such as the data preparation pipeline I use in this project file. So I got a whole bunch of rules. And I also use extra stuff. I define my directories up front, and I have not only one rule, all but I have like multiple rules for unzipping, for auditing, for testing. I have different rules to build different data sets, playlists, followers, listeners of followers, placements, go on. These are all the rules. And, maybe you've been thinking, well, I got like 3 rules to define. But if you actually work on like data intensive projects, this is how your make files are going to look. And actually, if you look at my files in this directory, which are like a bunch of them, and actually this directory is very, very clean, I wouldn't know just by looking at these files in what order to run. It's a complex thing, and make files really help you keeping track of the order in which files are going to be executed. There are a couple of extra rules that I would like to go over. You may have observed these rules all and other rules that I've defined. These are weird rules. We call them phony targets because these targets don't really produce any output. It's just like a wrapper for running multiple rules, such as in this example script right here. I got a rule, it's called all. What are the prerequisites? The rule 1 and 2, and then I have a rule 1 here, and it issues the command touch1.txt. The other phony rule that is frequently used is a clean rule, to kind of clean up all your generator or temporary files to make sure you can start from fresh. It's extremely important actually to wipe your temporary files in, occasionally, well, actually quite frequently, because you want to see whether the code that you've written, given the raw data that you have downloaded, actually reproduces your results over and over again. Not to kind of check that the numeric results are stable, but that your code just works. Because that's important. When you stop working on a project for a while and you want to get back to your project, you do want to make sure that everything works well. And then the other thing that you may have seen in the make files that I've shown you are variables. So it's like quite cumbersome to always specify like directory names manually, so you can define variables. So what's the summary here? How do you get started in defining your pipeline and automating it? Well, first of all, create a directory structure consisting of source code files, generated data, and raw data. Second, create pipeline stages such as data preparation, analysis, paper, but depending on the project that you're working on, be flexible and adapt it. Number 3, move your source code into these pipeline stages, or start writing new source code. It's extremely important to break up your code into small chunks rather than one giant script. And then 4th, use make to automate each pipeline stage. Thanks a bunch for watching on how to get started using pipelines and automation. But the most important thing really is get started right away. Use those 4 steps to start organizing your projects in a better way. Thanks a bunch for watching.